Floating in zero gravity can put quite the squeeze on the human brain, according to a study published in the New England Journal of Medicine on Wednesday. Researchers scanned astronauts' brains using magnetic resonance imaging before and after varying lengths of space missions. The MRI scans revealed brain changes in the majority of the astronauts who returned from long-term spaceflight missions. There appears to be increased cerebrospinal fluid and an upward shift of the brain within the skull, wrote Rachel Seidler, a professor at the University of Florida's Department of Applied Physiology and Kinesiology, in an email. Seidler has participated in similar studies but was not involved with this one. Similar to our recent findings, there are spaceflight duration effects, she said. This additional cerebrospinal fluid squeezes the brain, making the space between brain regions appear smaller. It will be important to follow this up with additional studies to examine how long-lasting these changes are. Cerebrospinal fluid surrounds the brain to help it maintain normal function, and a disturbance in the balance of this fluid can cause changes in cognitive brain function, wrote Dr. Donna Roberts, lead author of the study and associate professor at the Medical University of South Carolina, in an email. We hypothesize that upward brain shift and expansion of tissue along the top of the brain may result in compression of adjacent venous structures along the top of the head, she said. While we cannot prove it yet, we suspect that this may ultimately result in a decrease in the outflow of cerebrospinal fluid and blood from the head. Astronauts experience a fluid shift when they enter zero gravity that effectively turns some of the natural processes in the body upside down. Though the adjustment to microgravity doesn't take long, other issues arise within the first few days due to a phenomenon in which the head naturally tilts downward between 12 and 20 degrees in zero gravity, causing disorientation. As soon as you arrive in weightlessness, the fluids start shifting in your body from the lower part of your body into the upper part of your body, Dr. John Charles, NASA's Human Research Program Associate Manager for International Science, previously told CNN. Your organs of balance and your inner ear immediately sense there's no gravity pulling down on them anymore. This causes something known among astronauts as bird leg syndrome, because the fluid shift causes them to have puffy faces and thin legs. It also makes them less thirsty, dulls their sense of taste and causes a stuffy nose feeling similar to allergies. Space motion sickness also affects about 79% of astronauts in the first 24 to 48 hours in microgravity, creating a loss of appetite, dizziness and vomiting. Of the 34 astronauts who participated in the NASA-funded study, including 28 men and 6 women, 18 were part of long-term space missions on the International Space Station. There were originally 35 astronauts, but one was excluded for technical reasons. 16 were part of short-duration shuttle flights. The average length of the long-term mission was about 165 days in space, and the short-term mission averaged to around 13 days in space. 17 of the 18 long-term astronauts experienced a narrowing of the central sulcus in the brain. This was present in only 3 of the short-term astronauts. The central sulcus is a critical area that separates the region responsible for much of our motor function from the region that regulates input of sensory stimuli, Roberts said. It's important for astronauts adapting to space because of the critical mission tasks and the continuous changes they have to make in such an extreme environment. The upward shift of the brain overall was seen in 12 of the long-term astronauts but none of those who participated in short-term missions. And a narrowing of the cerebrospinal fluid spaces at the vertex, the top of the skull, was apparent in 12 long-term astronauts but only one of the short-term astronauts. We don't know if these changes will continue to worsen with mission duration or if they may eventually reach a plateau, Roberts said. Our results highlight the importance of brain imaging of astronauts on long-duration missions, not only when they return to Earth but also over time back on Earth to assess whether or not these structural changes are persistent or return to baseline. In addition, 3 astronauts in the long-duration spaceflight group experienced visual impairment and intracranial pressure syndrome, or VIPITS, one of the more recent effects of spaceflight noticed over the past 5 to 7 years. Scott Kelly and other retired astronauts in their late 40s and 50s have complained about their vision being slightly altered. Some have required glasses while in flight. It changes their visual acuity, Charles said. They're not able to see things up close. It's like advanced aging. T.